Hello everybody, this is Mrs. Wild from your WCA Earth Science A class with yet another portfolio. Aren't you excited? The name of the portfolio is Analyzing Galaxies, and what we're going to be looking at is data from different spectrum from stars found in galaxies outside of the Milky Way. So if you remember, a spectrum is like the rainbow of colors that you can see when you take white light and break it up with a prism into the colors of the rainbow, right? Red, orange, yellow, green, blues, indigos, violets. So this is the visible portion of the spectrum that we can see with our eyes. If we put it through a special type of filter, that prism light can then also be even further kind of isolated, and you can see bright lines that will form at very specific wavelengths here. So this is what's known as the spectrum. We've got 1, 2, 3, 4, 5, 6 brightly colored lines. Those are the ones we're concerned about because those are our visible part of the spectrum, right? This is where the light from that particular star is shining most brightly. It tells us the elements that make up the star. So we actually did a previous activity where you kind of looked at that and looked at the elements that makes up stars based upon the spectrum. But now what we're going to look at is how we use this information to tell us whether a star is moving away from us or towards us. And it can also give us kind of a relative speed of how fast that star is moving. All right, so we're talking about two different types of changes, what we know as redshifts and blueshifts, which are all types of Doppler shifts. So you will need this worksheet. You can download this and use it and then save it. What you shouldn't be doing is just typing into this box because it's going to disappear if you do that. So don't do that. You either have to download it or you're going to use the link on my intro page and it's going to open up this Google Doc for you to use. Now you can't use the Google Doc as is either. You're going to have to download that to your computer to use, okay? So I lost my page again. There we go. So we're going to go to the spectral lab activity, and I have my computer zoomed in really far because I'm very blind, but we're just going to go and hit the continue button. We're going to look at if we can indicate whether it's red shifting or blue shifting, and so we're going to click on shifting light spectrum. So a red shift occurs when an object is moving towards you, and a blue shift occurs when an object is moving away from you. That's how we see the changes in light. So if an object is giving off light, the light from that object will blue shift if it's moving towards you, and it will red shift if it's moving away from you. We can also see, or we can also observe the Doppler shift with sound. You probably are more familiar with this. So as a siren moves towards you, it's going to change in pitch. And if it moves away from you, it does that as well. So it's like, you know, nee, 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 nee. So towards you is a higher pitch, away from you is a lower pitch. Because as it moves towards you, the wavelengths kind of squish together. I always think of it like there's these waves that are emanating from the object, and as it's moving towards you, it's actually running, those waves are kind of running into you and piling up a little bit, so it's squishing together. And as it's moving away from you, the waves are actually being pulled apart a little bit, so it's a longer wavelength, which translates into a lower pitch or a redder color. Okay, so let's click on Learn More. We can see this little kind of scale, I guess. Stationary meaning it's not moving, right? If it's moving further away, we slide it over to the right. If it's coming closer to you, we slide it, or this is actually, I'm sorry, if the object is farther away or closer to you. Okay. So let's see. Let's go to farther away. So we're going to notice, and hopefully you've seen a change. I want you to go back and look at it again. Okay. These two right now are identical, left side and right side. But if we go farther, what you're going to notice is like this group of 3 lines is now a little further to the right. This group of two lines is also a little further to the right. See, it's a little bit, there's a little bit more space here than there is here. Does that make sense? So we're saying the one on the right here is red shifting because it's shifting these two lines closer to red. If we move it to the other end, I'll go to stationary first, kind of reset it. We go to closer. Now notice that these two lines have shifted towards the blue. Okay? So if the galaxy moves farther away, it's going away from you, you get a red shift. So I always just pick two lines to look at because it's easier. So it's shifting to the red. And if that galaxy is moving closer to you, those two lines are actually shifting in the direction of the blue end. So they're going to the left. To the left is a blue shift, to the right is a red shift. So when you get to your lab report, you're going to just explain what's happening here, and you're going to describe how the spectrum changes. So what's going on, and as you're changing the slider, right? Then you're going to go down to explore further. And now you're going to be looking at each individual galaxy. And this is where you're going to start to collect some data. So you'll have a data table to fill in here. Galaxy number 1 is over to the left. It says galaxy number 1. And you're going to see the spectrum. And now you're seeing what's happening to it. Again, pick like a little chunk of it. Like, for example, these two lines. Do these two lines shift to the blue end? A mirror image right now. Or are they shifting to the red end in the below? So you're going to click blue or red and submit it. And then you're going to put that information on your table, right? Galaxy 1, is it Redshift or Blueshift? It says to use check marks. I think you can if you want to, but you can also just put an X in here or whatever. Now let's think of it from the perspective of the galaxy. If objects are moving towards the Milky Way, so let's say that this is the Milky Way galaxy. Nah, I don't know if that's a great example. If I'm trying to think of, let's see, I'll just get you a new, excuse me for a moment, a new document so I can have a blank piece of paper to draw on, right? So if there is stars out there, let's see, that are moving. Here, let me just draw it on a piece of paper, you guys, because seriously, technology sometimes can be a pain in the butt. But if this is the Milky Way, right here, right? This is our Milky Way galaxy. Can you see that? Ah, let's try that again, you guys. I was trying to be smart. Here we go. Milky Way galaxy. If I have another galaxy, so galaxy 1, right, over here, if it's moving towards the Milky Way, if it's moving there, eventually, let's say you start off with the universe this big. If it's moving towards the Milky Way, the whole universe is getting smaller and smaller. So we say the universe is contracting at that point. If all of the galaxies are moving away from the Milky Way, then we say the universe is expanding. So what you have to determine on this is this evidence of an expanding universe or a shrinking universe? So basically, if it's a redshift, it's expanding. If it's a blue shift, it's going to be shrinking, okay? And then lastly, you need to answer the analyze questions. What pattern do you observe? What can you infer about the position of the galaxies 100 million years before this photo was taken? In other words, I know that can be tricky, but were the galaxies closer to the Milky Way in the past, or were they further away from the Milky Way in the past? And again, if our universe has expanded, if it's expanding and we rewind time, would those galaxies be closer to us or farther away? And how do you think this relates to the Big Bang Theory that you've learned about? Number 6, how does your analysis of the spectra relate to the Big Bang Theory? It's kind of just a restatement. It's similar to question 5, but you're looking at the spectrum itself versus just the pictures. And then I want you to draw some conclusions. Just give us a summary of what you learned. It's going to use some of the data. You can cite some of the data for examples in there. So we just want to practice scientific writing here. Okay, so you're going to write us a summary. Make sure you use all of the good conventions, capital letters, periods, commas, paragraphs, that kind of stuff. And you're going to give us a little summary of it. Pretty simple activity. If you have questions, let me know. I just realized I can draw on here. That's super cool. So I could have been like, so here's the Milky Way. Technology, Mrs. Wild, right? And here's a galaxy number 1. And this is the whole universe. And if it's moving towards the Milky Way, then in the future, it'll be here. So then the universe would be shrinking. So that was what I was trying to do before, but I was struggling with the technology. But if you have any questions, you guys let me know. You just give me a call or send me a webmail. Have a great day.